Okay, here we go. Welcome. Not that I haven't seen you all day or anything, but welcome to Linux installation and configuration, spring 2020, yay! So obviously, first class day was yesterday, January 13th. Right there. Our first class day is today, though. Yeah, I know. I put the whole range there. Last class day is May 1. That's that Friday. However, and I'm just saying this up front so there's no confusion toward the back end of the class, any homework that I have assigned to you or that we have agreed upon to get in by the end of class, and for those of you that can't see me, I'm air quoting, by the end of class, it is actually due the day before that. That will be April 30th. So if we have a deal, or it's just last week's worth of stuff, whatever it is, it's due April 30th. Now, don't get that confused. Each individual week and whatever has its own deadline that following Sunday. But if we have a deal or something in place, your last ultimate day is April 30th. So keep that in mind. Y'all have done this before. Y'all know what my classes look like outside of the fact that they look weird now. The whole of Moodle changed, so yay, we can enjoy that together. The big thing for us is the news forum. You don't have to go check it manually or anything like that, but you will. This is where I'm going to go post. I think you know what? I'm not going to say it because it's going to be on the video. Anytime we have a day off, I will let you guys know, or if it's a surprise thing, or if I'm sick that day and I'm just like, don't even bother sticking around till 11:30 for this class or whatever. If I'm going to tell you guys something, I'm probably going to put it there first, and I'll add it to Slack and everywhere else. But again, you don't have to go check this news forum because anything I post there within 30 minutes gets sent to your email. So long story short, check your email. Keep your eyeballs on the email. Check it every evening or every morning before you get here. That way you'll know of issues before you get here if it's something like that. If you're away, if it's 11:30 and you're not going to be able to make it, but you still have time to dedicate, you can get into WebEx. This is going to allow me to talk to you, and which reminds me I should share my screen. There we go. Cool. Anyhow, so if that's the case, just click on WebEx, sign in. You'll come into my class, and you'll see and hear all of that kind of fun stuff, everything that we're covering that day. If you cannot do that, of course, YouTube. I'll post everything that I do on YouTube, usually by the end of the day. Usually. The book. If you haven't gotten it by now, Amazon's probably your best choice because they'll get it to you faster-ish. And boy, is this fast. Here we go. What? I know, man. It's happening. Anyway, click on the link. Go buy that book. You can get it digitally as well. I don't require you to have any particular type of book, just so long as you have the text. There's some things that I may gloss over in a quick way because we only got an hour and a half. So do skim over the book at the very least. Skim it for sure. Anything that I don't cover in the notes or in the lecture will be covered there. But there won't be a whole lot of that stuff. But like command examples and things like that might show up in the book that we don't have time for in the lecture. So anyway, make sure you have that. This is what I was telling you in the last class. I don't know how you can magically link to the exact syllabus or whatever. So if you need to find me on the syllabus, assuming this page will load. No! The database is broken. Yay! Those kinds of errors? Database errors. Oh, wait. No, there it goes. Yay. Wait for it. There we go. Control F. Hey, we were just talking about that. Control F. Chavez. There I am. Find my course, which is IT something. Oh, did I miss it? I think it's ITSC. There it is. Linux install and config. Click on that. Same basic deal, right? Rules, what everything's worth, etc., etc. So be aware. This is how that's going to work. We've got a quiz and we got a lab. That's what we do. That's all it's going to be. And the quiz, I probably could have, you'll see what I'm talking about in a minute. You'll do the lab first and then the quiz. I think there's quite a few of you last semester that told me that's how you do it anyway, because when you do the lab, a lot of the answers for the quiz become like you know it at that point. So I've organized it that way because it seemed like a lot of people were doing it that way. And this might help out a little bit. But, I mean, you don't have to do it that way. You can do it in whatever order you want. As long as I get my homework in, I'm good to go. Everything else unchanged from last semester, right? Do your own work, etc., etc. Those are the rules. Those are the rules. Maybe? Oh, there it is. Yay, that's what the book looks like. XK0004. That is the test that we are gearing up for. So if you're curious, if you want to go ahead and buy your voucher or something like that, you can go do that. That's there. We're going to cover everything that you need to know for that test. It is not mandatory, though. You don't have to take that certification test at all. It's not part of the curriculum, but I'm gearing you up for it. So if you want it, you can get it. Linux Slack channel, go join it. Anything that is not like super duper important, I'll just probably post there. I don't want to like flood you guys' email with stuff. So if it's of medium importance or whatever, like I have, I fixed a typo, or I forgot to mention to take a screenshot right here, or something like that. If it's something simple like that, I'll post it in Slack. So for those small advisories, I'll let you guys know there. All right. Y'all okay with the intro? That good? Nothing changed. It's all the same. So here it is. This is where I'll post a video as well. You won't have to go into each section. It's going to show up. I think you might have seen it a little while ago. They'll show up at the top of each individual section, just like this. Like this. I keep saying it. There it is. Like this. But this is just for you to easily get to it or whatever. And I've got all of last semester's videos. Most of those will be relevant, so I'm happy to give you guys links to them and make you aware of them, get you to them, no big deal. However, the course or the certification has changed. The certification I was teaching to last semester retires in a couple of months. So before y'all will be done, the old test will retire. So I've moved us up. So we're studying for the new test now, which unfortunately covers a wider breadth of things. But as we were talking about with Docker and all of that kind of stuff, we're going to cover some of that in this course as well, because that's where Linux is moving to. So you'll get a little bit of what we were talking about before. So anyhow, let's dive in, y'all. You ready? Me either. Let's wing it. All right. So the vast majority of everything that you're going to need for an individual chapter or for an individual week is going to be right here. So I've distilled it down for you, got out all the cruft, and yeah, I would venture a 90% guess that, I would venture that 90% of what you need to know is right here. So if this is all you consume, you'll squeak by. You'll be okay with just this. But I really, really do encourage you to read the book. I mean, you spent money on it. So definitely at least stick your nose into it every now and then. At least skim the chapters. That would be extremely beneficial if you can't read the whole thing. But if you can read the whole thing, read the whole thing. It's got really cool pictures and examples that I don't necessarily have in the notes. Okay. So let's do this. So y'all know some of this stuff, but I want to spend some time on it anyway. So the basics. Windows has its kind of nomenclature for things, and Linux tends to as well. But a lot of the stuff that we're going to talk about here has some crossover, mostly. So binaries. These are the programs that you run. In Windows, if you're running Firefox and you double-click on it, that's a link to a binary somewhere in the system. And that's I've got the example up here, firefox.exe. In Linux, it's just Firefox. There's no extension for that. There's no .bin or anything like that. Same with Nano and VI and apt and VS Code. All of those things, if you're launching them, there's a binary behind it. And so binary has, for the most part, become synonymous with a program that you run. And it could be a service, like my Apache instance that is producing the web page that we have accessible on the outside world, right? You type in my IP or my domain name, you get my website. Apache is running a binary in the background. There's a service that is running back there to answer those questions like, hey, can I see your website? So there's a binary back there. Libraries. This is an idea that exists in Windows as well, though slightly different. Libraries are shared code. So, for instance, if you wanted to write a program for Linux, maybe like a chat program or something like that, right? Simple, all you do is send text back and forth. The thing that you would have to do if libraries did not exist is write the entire networking stack for that program, right? Remember the OSI model? You're going to have to write code for every layer. Well, layers 1 through 4 and at least one layer above that. You'll have to write code for every single layer. Except Linux has libraries. So layers 2, 3, and 4, that code's already written. So all you do is say, I need the libnetwork.so. So what you do is you take that library and link it to your code. You don't write any of it. It just works. That stuff is already there. And so all you do is write the chat protocol. And it lives on top of libnetwork.so. And those two things combined create the whole chat app. So I know we're not programmers, but the example really works better that way. But there's a, for everything, right? Gparted or parted or fdisk, all these utilities that you would use to mess with your disks in Linux. Those things are really more just a front end. The libraries that live behind it to manipulate the disk itself already exist. Fdisk never had to write that. They just link to the thing that already exists. So libraries are shared code. They already exist in the operating system, and all you have to do is link to them. Configuration files. So we were mentioning registry earlier. Linux doesn't have a registry. Each individual switch, toggle, yes, no answer is in a configuration file somewhere in this directory, etc. And it literally stands for etc. But it has become the home for every configuration file on the system outside of weird off-the-wall issues that you might run into. If it's widely known software, the configuration lives in etc. always. So these configuration files will dictate how the binary that you launched up here, you double-click on Nano, and you've saved defaults. If it's a global default, if you want every user on the entire computer to be affected by this default, right? Like it has a heading or a comment at the top that says, this document was created at TSTC West Texas or something like that. You can configure that in a file in etc. So if you want Nano to behave differently, you'll configure it there. The example I have down here is SSH. So you guys may have been slightly exposed to SSH in Cisco. Maybe it was brought up. Oh, wait, in Network Plus. Did you bring it up at all? Okay. Oh, see. I know. So Secure Shell is just a remote way to get terminal access to something. It works on Cisco devices. It works on Linux devices. Windows it's now native to Windows. So you can do SSH to Windows too, which is something totally weird. But if you want to just run commands on a computer that you're not physically in front of, SSH will do that. Well, SSH has a configuration file that can dictate how people log in. So let's say that you didn't want people to use passwords at all. That begs the question, well, then how do you log in, right? Username plus a token, maybe a certificate that you created or something like that. But the way that you tell SSH to do that is right here in that file. You'll scroll down, and it'll say password authentication equals yes. You'll just backspace the yes and replace it with no. Save the file, Done. That's it. So config files are not difficult, but they can be massive. So there could be like 200 options in there. So it gets pretty unwieldy eventually, but that's the basic gist. Documentation. If you ever want to know where that configuration file lives because it's not in Etsy, it'll be there in the documentation. So whatever program you're trying to get a hold of, you'll do man on. So man this, man that. So man apt if you want to know more about the apt program. And I mean, it's an encyclopedia. It is literally the encyclopedia excerpt for that one particular application. So yeah, someone spent a whole lot of time writing down the instructions on how to use this stuff. Typically, that's the developer, the guy that wrote it, or the team that wrote it. Some unlucky soul gets voluntold to write the documentation. But a lot of times you always have some guy that just enjoys writing stuff. So hopefully that guy's the guy that gets it. Data is everything else. The pictures you download, the documents you create with OpenOffice, LibreOffice, Microsoft Office, whatever. The plain text files like I don't know, you just jotting down some notes, saving .txt files, things like that, videos, all that other fun stuff, right? If it ain't a binary, a library, a configuration file, or the documentation for the binaries, it's data. It's stuff you probably want to save. Everything else is pretty expendable. Linux itself is kind of an implementation detail. So if you blow away the entire Linux installation, but you still have access to the data, you can rebuild it pretty simply. Well, once you get a little more familiar with Linux, it'll be easier to rebuild things. All right. So libraries, just so you know, they live in lib/lib. Let me get a Linux going here. I think Ubuntu is probably the fastest one to get installed. And I'll show you some examples of some of this stuff as well. That way I'm not just telling. Let's get this going. I know you can do it. Yeah, we'll cover this in just a minute. I want to show you this. They've changed the way, if you update your VirtualBox, they changed the way you attach disks. It works a whole lot more like every other hypervisor in existence. VirtualBox was the only one that did it this way. But now they're the same. All right, so lib and lib64. Don't worry too much about the directory paths just yet. I'm going to explain some of that as this gets installed. But just keep that in mind. Libraries live in lib, which is short for libraries, and lib64. What do you think the difference would be between the two?
32.
And yeah, 32-bit, 64-bit. 32-bit libraries live here. 64-bit libraries live there. Okay. Some distributions, and y'all will see 3 this semester. This is up from 2 last semester, so hey, sorry. You get to learn a little bit about OpenSUSE as well. Some distributions decide that they just want to link everything to USR lib. Now, here's the thing. USR. It is USR and not user. However, because it is easy for me, and I tend to talk quickly, user is how it's going to come out. It does not reference a specific user. USR is really an acronym. It stands for Unix System Resources.
Convenient.
What's that?
It's convenient.
Yeah, exactly. Yeah. Acronyms are convenient, and that's why we in IT are just inundated with acronyms. So, Unix System Resources. So, when I ask you the question inevitably a little later on, where is your home folder? Where is it not?
In the USR.
It's not in USR. That's it. Exactly. It's not in USR. It's Unix System Resources, and you are not Unix, so you do not belong in there. That is where some distributions will put their libraries. And it is where some applications get installed, et cetera, et cetera. We'll go over more about that at a later date. So don't worry too much about it. Just I need you to know USR does not stand for user. It stands for Unix System Resources. Heck no. You don't remember me turning my nose up at password hints last semester? Ooh, boy, I can't stand them. All right, so when this happens, when you see, or when you, let's say that you're on a distribution that does do this, where they put all their libraries not in lib, like has been done in the past, they put them in user lib, you're going to see something similar to this. So it will just be a shortcut to this, and it will look like that. So if we are in lib right now, we can see that libdisplay2.so.1 links to this whole path, that whole nasty thing. So I don't need you guys to fully understand paths just yet. That is a topic that we're going to get to. But if you see things like this with this little arrow, and it's got two things, one on each side, it's a link. One points to the other one. Just like on Firefox, on your desktop, it's got this right here. There's a little up arrow. It's a shortcut, right? Links in Linux, shortcuts in Windows, same idea. Yes, sir. Yes, exactly. Keep pressing the wrong one. Right. Okay. And in other cases, additionally, not in other cases, additionally, you have different operating systems. All the different operating systems kind of have this idea that they will always point software. If a software depends on I've been reading that wrong. libsidplay. Anyway, the way that they'll do it is they'll name it like this: libthingy.so.1. Now, any program that you install on your computer, on your Linux installation, will point to this. And it will get redirected to this. Do you notice the difference between the two things? What's the difference here? Right, this bit. So this is a way that Linux can increment the version number, like fix things, patch things. But they do it on the thing that's being linked to. This name never changes. This is how you get a pretty stable Linux experience. Every program is looking at that thing, but that thing is really just a link. And every time we patch that library, this number here increments by 1, .2, .3, .4. But the cool thing about it is that we can delete that and replace it with stuff and do it again and again and again and again. 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever. And because this never changes, the software that you're running that depends on it doesn't know any different. It just works. It's a library, it's linked, whatever. I don't have to care about it. And that's really just how that works. And you end up with a pretty stable distribution that way. If you need to, let's say you've actually changed where your libraries live. This is it by default, lib and user lib. Those are pretty much it. So if you've added more stuff, I'll show you how to do that here. You echo LD library path, and it'll tell you if you have any custom library locations. So let's say you're programming stuff and you have your own personal libraries. You can do like plibs, personal libraries, create a directory there. Just have everything, or you can do this here, export whatever, and then /plib instead of all that junk. And then if you run ldconfig, it will add that to your list. It will say, all right, cool. So lib, user lib, and plib. Those are the three places I'm going to look for libraries. If it exists, cool. If not, I'm going to complain at you. If you want to figure out what libraries a specific software depends on, this is actually kind of interesting. And this is one of the things, once Ubuntu finishes, I'll show you. You use the LDD command. So first thing you really want to do is figure out, quit. You want to figure out what exactly, or where exactly your binary lives. So you'll do which Firefox, and then Linux will spit out to you this. It lives in user bin Firefox, right? Unix system resources bin Firefox. And then if you run LDD user bin Firefox, it will just straight up tell you, there's like a list. Firefox depends on a ton of libraries. The networking one being one of them, because it's obviously a networking thing. So it will just list off all the libraries that it depends on. So if any of those libraries are missing, either Firefox won't launch, it won't turn on at all, or it'll be limited in functionality somehow because it doesn't know how to do whatever that library allowed it to do. So like Wildvine, if it didn't have the Wildvine library, you're not watching Netflix, right? So things like that. But the rest of the internet will work just fine. YouTube would work fine. All right. So overall, libraries, shared code. If you need to figure out what depends on it, there it is. If you need to add some more library paths, there that is. Run that after you're done, so it will be aware of those changes, and then the different types of software. So, speaking of software, these binary things, how do we get them? That's kind of important, right? I mean, a server is nothing until you add services to it or a Firefox to it. Once you add Firefox, it becomes a machine that you can browse the internet on, right? Once you add Apache, it becomes a machine that can serve up a web page. Once you add, just on and on and on, like that. Whatever you want it to do, it can do it. You just have to add the binaries, or in this case, packages, to make all that work. So we got to talk about 3 different package managers and 2 different packaging styles. All right, so you have to kind of get away from the Windows paradigm in this case. What we're really looking at is, in Windows, the way that you deal with software is essentially you just go out to the website and hope for the best, right? You download the exe, you double click on that exe, and it hopefully works. And if it doesn't work, well, you email the whoever, and that is what you end up with. In Linux, it's a lot different. In Linux, it behaves a lot more like the Android, the Play Store, or the App Store on your iPhone. There is a repository, right? A big old list of all of the different things that exist. And you can search it, and when you find something that you want, you can install it. The idea here is that everything that exists in that repository, wherever that is, wherever that lives, is vetted by somebody, right? The base system repositories, the base list of software that is available to a Linux server or distribution is vetted. And there are different stages of this. Like Red Hat has the base repo, and everything in the base repository is absolutely 100% vetted by Red Hat themselves, which means that they guarantee there are no viruses in it. They guarantee that it will work with all versions of Red Hat. That is, if it's in the base repo, it's guaranteed to run, essentially, and you don't have to think twice about installing it. You typically don't have to jump through a whole lot of hoops if you have very strict policies on softwares that you can install. Usually the policy will say anything in the base repository of RHEL 7 is okay to install, right? You don't need to do a security audit on it. There are literally people getting paid thousands of dollars to do that for you. Right? That's why you want Red Hat. Same with Ubuntu. Ubuntu has, it's not called base, it's called main. They have main, and it's the same deal. Canonical, the company that owns Ubuntu, pays a lot of people to vet that software. So if it's in main, install it. All right. So RPM and Yum. Here's what we get to talk about. RPM stands for Red Hat Package Manager or Management. And it is used for pretty much every Red Hat derivative. So that includes CentOS, sort of SUSE. They changed the U, it's uppercase now. And Fedora. So just a quick background. I think we've talked about this before, but just a quick background. Red Hat is now owned by IBM, so I guess I could say IBM. But Red Hat is kind of like the granddaddy of a lot of different distributions. Red Hat is the base system that CentOS is built off of. And CentOS is really just a clone of Red Hat with all the logos and stuff stripped out. So if you want to test software, if you want to say, hey, I don't know if this software runs on Red Hat or not, but I don't have a Red Hat subscription to just like install the server. It's kind of like Microsoft where you have to have a sub, and they'll give you the software at that point. But CentOS is what's called binary compatible. If you install CentOS and it works on CentOS, it's going to work on Red Hat. So in this class, we use CentOS. It is essentially Red Hat. There is a group of people. It's owned by Red Hat now. They actually acquired the whole thing, so it's even better. But there was a group of people that went out and got all of the source code for Red Hat, because with Linux, the license that you have to put everything under is a GPL license, which means that if you code it, it's free. For anybody to go inspect the source code, compile the source code for themselves, it's all free, all of it, every bit of it. Red Hat does have proprietary software, though, so they're not bound by that fully. But if it touches or extends the Linux kernel, it has to be free. That's part of why the Linux kernel has been so successful. But anyway, CentOS basically took all that source code, compiled it all, and then gave it to people. And we're like, hey, here's Red Hat. It's called CentOS now. Here you go. All the stuff that was freely compilable, they put it together and gave it out to people. Red Hat then bought that and now streamlined that. So the new CentOS has come out way quicker. SUSE doesn't do that. They're their own thing, but they do use the Linux kernel. So SUSE is more like Red Hat than it is like CentOS. But we'll talk about more about SUSE here in a little bit. Fedora, if you want to look into the future, Red Hat is a slow-moving distro. When they release a distribution, if they release Firefox 68, that's where it stays. It is Firefox 68. Firefox came out with 7.2 the other day. You know what CentOS did? Nothing. They don't do that. Firefox stays. And then security patches get applied to it. That's it. No new features, no things that might break anything, security patches. If it affects the security of the application, it will be patched. If it does not affect the security of the application, it will not be patched. That's how Red Hat can stay stable. That's how people can run Red Hat. If you've ever worked for the government and you've ever dealt with Linux in any way, that OS stays the same for like a decade. A decade. That's Red Hat. They release a thing and it's got 8 years of wide support, and then you can feed them some money to get 4 more years of support out of it. So Canonical's starting to do that. They give you 5 years on top, and then for, I think it's 2 or 3 more years you can pay for. And they'll keep giving you security patches. If you don't want to update, they'll just keep doing it. So it's just something that when you're running Linux and everything is coded for Linux, that specific version of Linux, there's no changing it. Because it cost $1 million to write that software in the first place. I'm not going to spend another $1 million to write that software again. So the idea with that is stability, right? That is why Linux. That is another reason why Linux has gotten so popular with pretty much everything. Everything. Amazon runs on Linux. Microsoft Azure. We were talking about Azure a little while ago. They came out with a stat not too long ago that said that more than half of the VMs that they run on Azure run Linux. Not Microsoft, Linux. So just interesting tidbits. All right, man, I was really hoping this was going to be a little quicker than that. But anyway. So RPM. Think of when you go get Windows software, it ends in .exe or .msi. Basically, that's what RPM is. It is a package that describes how to install software. Where you put the software. Is it in user bin? Is it in just bin? Where is it? You install it somewhere. It references every single library that is required to run that software. And it contains this. It contains a signature inside that verifies the validity of that package. So if you run RPM -K and the name of your package, it will do a checksum on it. So it'll basically run the math, spit out a number. If that number matches the signature inside the RPM, it'll match and say, all right, this RPM is good. The author that gave this package to you did give you the right package. It matches up. So if you install it, it's good. If something goes wrong with it, it's not that broke it. And you're going to realize here in Linux, there's always a million ways to do something. So -K, capital K, is the way to check the validity of a RPM package. --checksig is the same thing. Same thing. So you can use either or, but never both. So if you check it, then you want to install it, this is how you do it. RPM space -I for install, V for verbose, so like tell me everything. And I forget what H is, but once we get a Red Hat distribution up, I'll take a look. I'll show you guys how to look at what each of these things mean. If you want to verify that the package is still installed correctly, nothing has been corrupted, it will do that same check signature thing, but you use V after it's installed. So RPM -V and the name of the package. And it will go through, it'll check everything, and it'll say, yep, this package is installed correctly, and it's still installed correctly. If you want to remove a package, RPM -E. Cool. Now, these are all local packages. This is the way that you would do it in Windows. You'd go out to a website, you'd download an RPM, you double-click on the thing, or in the terminal, you would use these commands, and it would do whatever it is that it needed to do to install that package. That stopped being the preferred way to install Linux software about 15 years ago, but it's still useful. If the software that you want to run is not in those repositories I was talking about before, this is your best bet. Go out to the software manufacturer's site, download the RPM, and install it like this, and it will work, as long as the libraries are available. Here's the better way. Well, here's an intermediary way. So Yum, Yellow Dog Update or Modified. Quick history, Yellow Dog was a Chinese distribution that invented one of the first people to invent package management. Package management is a fancy word to say, I don't want to go out to the website and download this. I just want you to handle it for me. So that's where those repos come in. They're just stacks and stacks of software. And Yum is your way to say, you see that big old list of software? Go get the one called Firefox and install that for me, and take care of the libraries, and keep it updated, and don't ever ask me about that software ever again. Just like your phone, right? You go and you install the WebEx app. Every time WebEx says it needs an update, it just takes care of itself. That's how this works as well. But well before Android and iOS ever existed, right? So the idea of these stores existed way before we had them now. Anyway, so you can install RPM packages with it. So all that RPM stuff, you can do it a different way. Yum install and the path to the RPM. Whatever that is. Yum will take care of it for you. If the libraries don't exist on the system, it will reach out and get them from the internet. So it's probably the preferred way to install RPMs. If you want to install software that you don't have the RPM for, right? Like I said, you don't want to go out to the internet, you don't want to download that RPM, you don't want to do none of that junk. Here you do it. Here's how you do it. Oh, highlighted too much. This one. Yum install Nano. And Nano's a text editor. So that's it. Red Hat will check the internet, go get the newest version, download it, install it, make sure all the libraries are there, all the dependencies that it relies on, everything. And then all you got to do after it's done is type in Nano. It works. That's the way to do Linux package management. On Red Hat. And if you want to get rid of it, Yum remove Nano. But the cool thing about this package management is that you don't got to care. Like in Windows, there's program data for global stuff. There's app data for user configured stuff. There's registry entries. There is the stuff that's located in program files. All of that. Nope. Scratch all that. Not in Linux. Those things exist. Configuration files exist. All that stuff exists. But you do not have to care about it. The package manager, package management, takes care of it for you. That's all there is to it. So in newer versions of CentOS, Yum has been replaced with DNF. But do not worry. Everything that used to work with Yum, all those commands, install, remove, update, checksig, those things, they all work with DNF. So the only thing you got to remember is, Yum's not on the system, it must be DNF. So everything else stays the same. Swap Yum with DNF and you're golden. So if you ever see me say Yum and the question asks, how do you do this with DNF? All you change is Yum to DNF and you get 100% on that question. Now that I said that, I will never ask you that question because it's that easy. So DNF stands for Dandified Yum. Every time I've ever seen DNF, it stood for did not finish. So I don't think that's a really good acronym. But anyway, whatever. It stands for... If you ask the Red Hat guys, they'll tell you it doesn't stand for anything. But when they were first cobbling together the first code for DNF to replace Yum, they were calling it Dandified Yum. So that kind of stuck. But either way, DNF, that's what it's called. And it's a replacement for Yum. That's all it is. But the command is command for command. Not a lot to learn there. So when I say Yum search GUI, how do you do it in DNF? See, it's that easy. DNF search GUI. So there are two different ways to search the repositories for software. So just like in Android and iOS, you click on an app, it gives you the name, and it gives you a brief description of what that particular app does, right? So if you do Yum search GUI, it will look for the word GUI in the description of that app. If it's in the name, it'll find that too, but it's more looking at the description or whatever. So if the GUI name was Budgie, if you did Yum list GUI, Budgie would not show up. But if you did Yum search GUI, Budgie would show up, because in the description of Budgie it says this is a graphical user interface parentheses GUI named Budgie, blah 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 blah. Right? So search searches the description, list searches the actual package name. So if you're 99% sure you know what the package name is, you can do something like Yum list SSH, and it will ignore the descriptions and just look at the package names. And it'll say, all right, here are the SSH things that we have for you. Oh, really? Really? Such a... Nah. Yeah. Yeah, swap that out with another one for sure. What did I do here? We'll come back to it. Okay. Here's what I'll do. Let me just do this real quick. No, go back. That one will do. So if you need to add additional repos, you can do that pretty simply with Yum --enable repo space the name of the repository name. There is a pretty popular repository that is maintained by friends of Red Hat called EPEL, Extra Packages for Enterprise Linux is what that stands for. Now, I was talking about before, base is something that Red Hat goes in, they vet it, they double check it, they check it for viruses, for compatibility, for everything. EPEL, not so much. They'll say it'll run, and they'll guarantee that it'll run, but if there are breakages in those packages, you don't get to call Red Hat for that. You get to just hope they fix it. Hope the guys that are maintaining EPEL fix it. So the way that you would do that, Yum enable repo EPEL. That'll add the EPEL repo to your stuff, and you'll get access to a lot of new software that wasn't available to you before. All right. So this deb apt stuff is pretty much the same exact conversation we were just having, The names are just slightly different. So instead of RPM commands, it's dpackage, Debian package. So Deb, short for Debian package. So quick history lesson on that one. Debian was created by a guy all by his lonesome, at least at the very beginning. Deb was the name of his ex-wife, and Ian was his name. So Deb, Ian, right? That was kind of an awkward situation back in 2011. So anyway, either way, Debian is now one of the most widely used distributions in all of existence. Red Hat is number 2. The reason Debian got so popular was because they had two things. They have a 100% commitment to freedom. And what that means is, not that they're going to go liberate you from something, but because the only software that is available by default is software that is unencumbered by proprietary licenses, right? That kind of does suck because you end up with, hey, I got this Broadcom Wi-Fi card, requires a proprietary driver. Debian ain't going to give it to you, not by default. You got to jump through a couple hoops to make it work. Now, they don't make it hard. You just go check a box, and it'll enable repositories that contain proprietary software. But by default, free. That's what they do, free. Red Hat skirts that line because they have proprietary software baked right in. So you have to be careful with that. But licensing is just a booger bear of a rabbit hole. So anyway, Debian came up with a lot of different things. The Debian packaging, the alternate to RPM, and the apt package manager, the alternate to Yum and DNF. So apt pretty much works exactly like you'd expect. So to install, let's talk about dpackage real quick though. Right, this is the Windows way. You go out to the internet, you download a deb file to install it, dpackage space -i for install, and then the package name .deb. And it'll do the same thing RPM does. Goes out, says, hey, got the libraries, good to go, it's installed, awesome. If you want to remove it, swap that I for an R, and it'll remove that package. There are situations where dpackage is pretty dumb. It doesn't touch the internet. If it's here locally and it works, cool. If not, can't help you, man. But there's a fix for that. So if dpackage ever runs into an issue where it needs libraries, but those libraries exist on the internet, it will tell you there are dependencies that cannot be satisfied. So the install has halted. Everything got put where it needs to be put, but the software's not going to run because it's missing libraries. The way you fix that, let apt take over. Apt install -f. So that'll force the install, F stands for force, will force the install of any libraries that got missed. So if dpackage ever runs into those issues, apt install F, it'll fix it, and then you can run your software. Everything will be good at that point. Let's see. So the better way to do that, if you know that the deb file is going to require new stuff or libraries that you don't have, just let apt handle the whole thing. Apt install, same as with yum install, path to the package name, and apt will take care of the whole thing. It'll say, you need these dependencies. Do you want them? I mean, of course you do. You're trying to install the software. Just say yeah, and it'll go through it. To install Nano, the only difference is swap yum for apt. So what I haven't told you yet is that Ubuntu is a Debian derivative. So that means that deb files and apt packaging, that's how you do things in Ubuntu. So to search, apt search. The older way, apt cache search. It's just easier to type this one, so I type this one more often than not. But they're interchangeable. They do the exact same thing. And I forgot to mention this up there. I do. I totally just missed it. Yum update will update all the packages on the system. So it'll reach out to the internet, get all the security updates, apply them, good to go. In Ubuntu, apt update will update the list of software, won't touch any of your software yet. It just gets the new version numbers. And it'll tell you, hey, you got like 100 updates to do, guy. So if you want that, apt upgrade. So in Ubuntu and Debian, it's a two-part thing. In Red Hat and its derivatives, one thing. Yum update. It'll go through and it'll say, hey, you got all this to do. Do you want to do that? Cool. Then hit yes on that, hit enter, you're good. With Ubuntu and Debian, apt update, it'll tell you how much, and then you have to run a separate command, apt upgrade, to actually install stuff. If you want to know where these repositories live, it's here. In Etsy apt, usually there's a file called sources.list. That's where all the important junk goes. That's where all the base file system stuff, or base system stuff goes. Anything else gets added to its own list in that directory. This will make more sense. I'm going to run out of time, but I want to, and I didn't have a VM set up, so I wanted to make sure that y'all guys saw all this. So on Thursday, we'll go through, like, I want to show you all these commands. I don't just want to talk about it. So anyway, if you look at those files, you'll see these things here. So the command that you would run for something like that is cat etsy apt sources.list, and then you'll get output that looks like this picture here. And of course, I didn't have enough time to go back and actually look at what went wrong with that VM, so see if I can get at least something going for us today. Anyway, there's some graphical tools that you can use. Aptitude is something that you can use, and it's still in the terminal. You're running it in the terminal, but it's got, like, you know, window form, and you can arrow around and do all that kind of fun stuff. So Aptitude is something that you can add and use. So I mentioned before, RPM-V will verify a package for you. Dpackage doesn't have anything like that. There's a secondary or a software that you can add called debsums that will do it for you, but by default, Dpackage can't do that for you. So, yeah, Yum, RPM and Yum win a little bit on that side. All right, so that's the bulk of it. That's the bulk of what you need to know this week. OpenSUSE, German company, really popular in Europe. So Red Hat's really popular here in America and in a lot of South American countries. OpenSUSE tends to have the whole European Union kind of taken care of. So you'll see a lot of OpenSUSE over there. They still use RPM, so it's still related to Red Hat, but they don't use Yum. They use something called Zypper. So if you want to search, Zypper SE. If you want to install, Zypper in, right? So if you wanted to do nano, Zypper in nano. If you wanted to search for nano, Zypper SE nano, right? To remove, Zypper RM nano, if that's what you're doing. If you want to see all the repositories, so in Debian, you literally had to like look at a file, a configuration file, to see where those repositories are. Zypper makes this easier for you. Zypper LR for list repositories, and it'll just show you. If you want to add one, Zypper AR, add repo, and then it'll be like the URL and the name of the repo in succession. So once this is done, this is being really, really slow. I think something's up with this install, so I'll get it on by Thursday for sure, though. All right. This is not going to come up often. However, there might be a question or two on your test about how to compile software. Okay, so the idea of compiling software. When you go out to the internet in Windows or in Linux or wherever, and you go download a deb file or an exe or an MSI or whatever, and you double click on it, that software is in binary format. You can run it. It's already good to go. If you're compiling software, it is not in binary format. What you've got is the source code. You have what the guy that wrote the software You have his keystrokes. That's what you have. And a configuration file, instructions on how to compile it. Lucky for us, we don't have to manually compile it, or we don't have to manually configure it. Sorry, we have to manually compile it. So you'll get it in a tar.gz. So think of tar.gz as a zip file. If you've ever seen those, I know we've seen zips a lot. Tar.gz is just the Unix file format for compression. So you'll get all your compiled or uncompiled software in a format like that. You extract that out to a folder, you cd into that folder, and then you do this, /configure. That will essentially let you get the software ready. It will say your architecture is x64, so 64-bit. You're running on this. You have this much RAM. You have this much storage. This directory exists. It goes through an entire script of looking at your system and verifying that everything that this software needs is there. Then you run make. Same. You don't go anywhere. You don't do anything. You just run make. And if the system was configured correctly, or that software was configured correctly, make will create a make file. I know this is convoluted, but once that happens, make install. And what that will do is it will actually run the small program that will install the rest of the stuff. It will compile the software from source, right? All you had before was text. It's taken that and creating a binary out of it. So you can actually do this with Firefox if you want. For some reason, you want to compile your own Firefox, you can do this. You can go out, get firefox.tar.gz, extract all that, run /configure. It'll get Firefox ready. You run make. It creates you an installer file. You run make install, and it will install Firefox in user bin Firefox. And it will install all of the libraries in lib or user lib, depending on your system, right? That's what the configure script is for. Does your system use lib or does it use user lib? It'll put everything in the right spot, and then you can just type Firefox and it'll work. But the benefit, why do you want to do this? There are entire distributions, right? So we have Red Hat and OpenSUSE and Ubuntu. There are entire distributions dedicated to not giving you binaries. You compile everything. One of those is called Gentoo. Some people run servers on that, man. That's crazy. But anyway, the whole purpose of that distribution is so that you compile your own software. But the reason that you would want to do that, the reason you want to actually compile your software is if you can read the source code, you can verify that it is what it's claiming to be. So, for instance, you do not get the source code to Microsoft Office. So you cannot verify whether Microsoft has added a backdoor to be able to look into your system whenever they feel like. You cannot audit that. You cannot verify that. With source code, you can. Now, if we're talking like behemoth software like Apache, like the web server, there's no way one person can parse through all of that. But you give it to a team of security researchers and they can. And they can go in and independently verify that that software is legitimate, is what they say or what they claim it is. And if you trust that third party, then you go get the version they verified, compile that for yourself, and you know for a fact that that software is what it says it is. And that's what Ubuntu does, and CentOS, and Red Hat, and all those guys. They go and independently verify that Apache is what it is. And when you apt install Apache, you're okay. It is what it says it is. But if you don't trust the chain of command for some reason, trust but verify, etc., 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 or if you can't even do that, you'll compile it yourself. That way, no intermediary in between you and the person that wrote the software, no one to make changes. It just is what it is. So if you need to go get these, Ubuntu, CentOS, OpenSUSE, I've already passed around a flash drive, so most of y'all already have it. If you don't have it, these are the links to go get it. I have the version numbers that you need inside of the course. So if you go to the lab, it should tell you, go get CentOS 8. Go get OpenSUSE. Where's it at? Oh, I didn't write it. OpenSUSE Leap 15.1. That way I have it. It's actually said. Oh, here it is. It's up here. CentOS 8, OpenSUSE Leap 15.1, Ubuntu Server 18.04. You're going to get 1804.3 if you go to the website and download it. But that's also what I passed around. So in this lab, each VM is going to have 2 CPUs, 2 gigs of RAM, and 20 gigs of disk. Everything is a 2, so keep it fairly simple. There really is something going on with all of this. I wonder if I just didn't copy it off right. That would make sense. What a bummer, man. All right, well, definitely Thursday I'll have this ready for us. I don't necessarily need you guys to stick around to watch me install something. Y'all installed Linux Mint last semester. These installs are pretty similar. I do go through each individual thing and tell you to, I tell you exactly what to be aware of. If I don't mention it, you're okay to just press next or yes, right? So boot the VM with the CentOS 8 ISO, select install, select disk to install the OS, and allow CentOS to use the whole disk. Set the time zone, enable networking. CentOS is the only one that disables networking by default. If you miss this, we're going to have some fun on Thursday. Do not miss this. It literally puts you in front of, you click on the network thing. There's when you're, right before you click install, there is a big bold thing that says networking. You go in and there's a little toggle, a dip switch. Flip it on. And that's all you got to do. All you got to do is just flip it on and it'll take care of itself. You can set a host name if you'd like. That way, not everything is named localhost. Give it a name. That would be nice. I don't require it, but it helps. Then, after you're done with all that, create a root password, create a secondary user, make it an admin. That's just a checkbox, and set a password for it. Then after it reboots, you'll accept the EULA. And using the notes, so I start to be a little more terse on the instructions on this, right? I'm not going to hold your hand through the whole thing. I'm not too terribly concerned with the install. We're just going to go investigate what happened during the install later on. And if I need you guys to do something a little more custom, we'll do a new lab that has you install a new one, but it'll be disposable. So once we create that second one, if we need to do something funky, you can just throw it away. Look for this marking. I got real tired of actually typing out the whole word screenshot. So I just do SS. Wherever you see that, that's going to match one of these. CentOS, number 1. The first time you see SS, number 1. Second time you see it, number 2. Number 3. Oh, wait, and then there's totally 4, weren't there? Okay, I'll go back and add that wherever I missed that. Where did I miss it? Update VS Code. Oh, I say to launch VS Code. Oh, I see what I did. Yeah, okay, I put it here. So that's right after you install it, and that's right after you launch it. I missed it right there. There needs to be a screenshot right there. That's what it is. Okay, all right. That freaked me out for a minute. I was like, I forgot instructions. Mostly. It'll be right there, but I'll fix that here in just a minute. Anyway, and then get into the command line and run that command. Take a screenshot of that. So it's going to be a lot more integrated with the quiz that you guys are coming up to next. So as I mentioned before, a lot of people were doing the lab first and then going back to the quiz. So I'm trying to facilitate that now. Seemed like it flowed a lot better when students did that. And then in OpenSUSE, you're doing the same exact thing. You install it, you update it, you install VS Code, you launch VS Code, then you take a screenshot of this command. Same deal. Same deal with Ubuntu. Except, and I'm going to update this too. This should just be Ubuntu-GNOME. So I'll change that. And that'll just install the entire GUI. So Red Hat and OpenSUSE, or SUSE, they changed that too. OpenSUSE, install a graphical interface for you by default. You don't touch anything. It just does it. If you follow my instructions, it just does it. In Ubuntu, it doesn't give you the option. Once you install it, you're just dumped down into a command line. And that's okay, because I have this extra section in Ubuntu to tell you exactly how to install, to tell you exactly which packages to install. Using the notes, you should be able to cobble together how to install that particular package. It's going to be a gig worth of stuff, so be near good internet. It'll help, I promise. But then the rest of it is the same. Update using the command line, install VS Code, launch VS Code, and take a screenshot of df-h-T. So once you do all that, cobble together all your screenshots, preferably, please, in order. I would so love headings as well, if you could do me that favor. As long as it's in order, I can take anything. Headings would be nice. If it's out of order, I cannot guarantee that I'm going to give you credit for it. Not because I don't want to. If I notice that they are out of order or whatever, and I can pick up on that, then okay, I'll give you credit for it. But I mean, I can't guarantee that I won't just miss it because it's just totally out of place, and I'm like, oh, what is that? I don't know. Keep scrolling, and then I go to the next one. Oh, okay, picks back up, right? So pay as much attention to the ordering as you possibly can, because it's 12 screenshots. Depending on how you do your screenshots, that might be 12 pages of stuff. So I'm going to be scrolling like a lot. So be careful. Put them in order if at all possible. All right. That's it for that lab. And this quiz, like I said, is going to be based off of the lab. So things that you did in the lab, I'm going to ask you to recall things. You've done them. Now it's time to tell me a little bit about them. So, and some of these you might even know from what I just said a little while ago. Which software packaging file type does Debian and its derivatives use? EXE. I'm just kidding. It's not EXE. That's Windows. So, what package manager does Debian use? And what command would you use to install the OpenSSH server package? It's going to be the one that reaches out to the internet, because the instructions didn't include you went out to the internet, you downloaded OpenSSH whatever that is, and double-clicked on it, or ran the command to install that package. That's not included. So assume this question, and the next two, because it's the same, are downloading this from the internet using the package manager. You're not going to get the package. You're telling the package manager to do it. Then this one, same question, but Red Hat. Next one, same questions, but OpenSUSE. This one, not the same question. So during the lab, you install VS Code. Its packaging name, so if you just want to launch it from the command line, you type in code, not VS Code. So that's just something you got to be aware of. How would you remove it? And there'll be 3 answers there, right? Notice the 3 question marks? If you've got the same amount of answers as there are question marks in my questions, you have the right amount. So keep that in mind. And they are in order, so please, in order. I'm looking for CentOS first, OpenSUSE second, Ubuntu third. Just give me those in order. If you want them out of order, please title them. That way I'll know you know they don't intermingle. They're not the same. Then I had to do it to you. Just check the notes. What are the 3 minimum things you need to be able to compile software from source? Right? There are 3 big things. Complex software requires more than this. But basic stuff you grab off the internet that you just want to get up and running with, that's all you need. Just 3 steps. Tell me what those are. And then how would you display the list of repositories? So if you go back in the video, I actually typed it out for Ubuntu. So the answer is there for that one. But CentOS needs something from Yum, and OpenSUSE needs something from Zypper. So that will be a little bit of a hint to get you there. And that's it. So all of the labs are going to be like that. They're going to have you do a bunch of stuff, and install software, configure software, do things, delete files, create files, move around the file system, all that fun stuff. And then afterward, there'll be questions that follow up on that. That just make sure that you didn't just move through the motions, that you did pick up some stuff. And there's nothing wrong with doing them at the same exact time. Open up the lab, do the lab, have the quiz open, and when you come across those answers, just drop them in. And that will constitute your grade. 33% for the labs, 33% for this, 33% for the midterm and the final combined. So it's like 17% each. So don't skip those, please. They are important. All right. What do y'all think? Yeah. Those notes will help a ton. On Thursday, I will show, not tell. Yeah, I just didn't, but yeah, VMs decided to just blow up. So we'll go through that stuff again real quick, but I'll show you the commands and show you the output, and yeah, hopefully that'll come together. And in the following labs, I'll do it at the same time. I just didn't have VMs this time.
It's kind of like learning 3 different systems at the same time.
It is. And the one thing that you're going to find out really quickly is once you get away from things like apt and yum and zipper, it's all the same. Every bit of it is the same. And then toward the middle and the end of the class, what we're going to do is I'll just allow you to start picking your favorite and just using that one instead. So
So is there like just like a universal for those 3? Something that works on all?
I mean, yeah, outside of like apt and zipper and yum and things like that, they all work the same. Etsy is universal. That's where all the configuration files are going to be. But Red Hat likes to do things a little differently than Ubuntu and Debian do. So while Red Hat may call their service SSH and Ubuntu calls their service SSHD, underneath it all, they're both using systemd. And if you know how to use systemd and you're handy with the tab key, it all comes out in the wash. It's all similar enough that it's applicable no matter what you do. All right, hang on one second. But other than that, lab day, we will quickly cover it all again. And at that point, I will show you the actual examples with all that.